Welcome. Let's understand exploring data. A preliminary exploration of data to better understand its characteristics. Key motivations include helping to select the right tool for pre-processing or analysis, making use of humans' abilities to recognize patterns. People can recognize patterns not captured by data analysis tools. Related to the area of EDA was created by statistician John Tukey. At the ADA, as originally defined by Tukey, the focus was on visualization. Clustering and anomaly detection were viewed as exploratory techniques. In data mining, clustering and anomaly detection are major areas of interest. In our discussion of data exploration, we focus on summary statistics, visualization, and overlap. Let's understand IRIS simple dataset. Many of the exploratory data techniques are illustrated with IRIS plan dataset. Under three flat types classes, we have setosa, virginica, and versicolor. Under four non-class attributes, we have sepal width and length, petal width and length. Let's understand summary statistics. Summary statistics are numbers that summarize properties of the data. Summarized properties include location, frequency, and spread. For example, mean is location and standard deviation is spread. Let's understand frequency and mode. Frequency of an attribute value is the percentage of the time the value occurs in the dataset. For example, given the attribute gender and a representative population of people, the gender female occurs about 50% of the time. The mode of an attribute is most frequent attribute value. Thus, notions of frequency and mode are typically used with categorical data. Let's understand percentiles. The notion of percentile is more useful for continuous data. Given an ordinal or continuous attribute x and the number p between 0 and 100, the pth percentile is a value of x such that p% of observed values of x are less than. For instance, the 50th percentile is the value such that 50% of the values of x are less than. Some of the measures of location are mean and median. The mean is the most common measure of the location of a set of points. However, mean is very sensitive to outliers. Thus, median and trim mean are most commonly used. Some of the measures of spread are range and variance. Range is the difference between the max and min. Standard deviation is the most common measure of spread of set of points. The formula for variance is given as shown. Let's understand visualization. Visualization is the conversion of data into visual or tableau format so that the characteristics of data and the relationships among data items or attributes can be analyzed or reported. Humans have a well-deployed ability to analyze large amounts of information that is presented visually. Humans can detect general patterns and trends, can detect outliers and unusual patterns. Let's understand histogram, which is a visualization technique. Here, usually shows the distribution of values of a single variable, divides the values into bins and shows a bar plot of the number of objects in each bin. Here the height of each bar indicates the number of objects, and the shape of histogram depends on the number of bins. Take a look at this example of histogram on petal width with 10 bins. Let's understand box plots visualization technique. It was invented by J. Tukey. It's another way of displaying the distribution of data. The figure shows the basic part of box plot. Here we have outlier, 10th percentile, 75th percentile, 50th percentile, 25th and 10th percentile. Let's understand scatter plots visualization technique. Here, attribute values determine the position. We can have two-dimensional scatter plots, or we can have three-dimensional scatter plots. Often, additional attributes can be displayed by using the shape, size, and color of the markers that represent the objects. It is useful to have arrays of scatter plots which can compactly summarize the relationships of several pairs of attributes. Take a closer look at this example. Let's understand counterplots visualization technique. Under counterplots, we have the partition of the plane into regions of similar values. These are useful when continuous attribute is measured on a spatial grid. The counter lines that form the boundaries of these regions connect points with equal values. The most common example is counter maps of elevation. Take a look at counterplot example. Let's understand matrix plot visualization technique. Here we can plot the data matrix. This can be useful when objects are sorted according to class. Typically, the attributes are normalized to prevent one attribute from dominating the plot. Plots of similarity or distant matrices can also be useful for visualizing the relationships between them. Take a closer look at this visualization of iris data matrix. Let's understand parallel coordinates visualization technique. Under parallel coordinates, instead of using perpendicular axis, we use set of parallel axes. These are used to plot the attribute values of high dimensional data. The attribute values of each object are plotted as a point on each corresponding coordinate axis, and the points are connected by a line. Thus, each object is represented as a line. Let's understand star plots. It's a similar approach to parallel coordinates, but axis radiate from the central point. The line connecting the values of an object is a polygon. Let's understand Chernoff phases. This was the approach created by Hermann Chernoff. This approach associates each attribute with a characteristic of a phase. The value of each attribute determines the appearance of corresponding facial characteristic. Each object becomes a separate phase, relies on humans' ability to distinguish faces. OLAP, online analytical processing, was proposed by E.F. Good, who is the father of relational database. Relational databases put data into tables, while OLAP uses a multi-dimensional array representation. Those representations of data previously exist in statistics or other fields. There are a number of data analysis and data exploration operations that are easier with such data representation. The key operation of OLAP is the formation of data cube. What is data cube? A data cube is a multi-dimensional representation of data together with all possible aggregates. By aggregates, we mean the aggregates that result by selecting a proper set of dimensions and summing overall remaining dimensions. For example, if we choose the species type dimension of the iris data and sum over all other dimensions, the result would be a one-dimensional entry with 3 entries, each of which gives the number of flowers of each type. Let's understand OLAP operations such as slicing and dicing. Slicing is selecting a group of cells from the entire multidimensional array by specifying a specific value for one or more dimensions, while dicing involves selecting a subset of cells by specifying a range of attribute values, which is equivalent to defining a subarray from a complete array. In practice, both these operations can also be accompanied by aggregation over some dimensions. Let's understand OLAP operations such as rollup and drillup. Attribute values often have hierarchical structure. For example, each date is associated with year, month, and week. The location is associated with continent, country, state, and city. And products can be divided in various categories such as clothing, electronics, and furniture. Note that these categories often nest and form a tree or lattice. For example, year contains months, which again contain date. A country contains a state, which further contains a city. This hierarchical structure gives rise to roll-up and drill-down operations. Let's understand. For sales data, we can aggregate or roll up the sales across all the dates in a month. Conversely, given a view of data where time dimension is broken into months, we can split the monthly sales or drill down into daily sales totals. Likewise, we can drill down or roll up on the location or on product ID attributes. That completes our tutorial. So feel free to pick up a tutorial of your choice and browse through it. Our sections are free and self-guiding. For further help, visit us at www.dataminingtools.net.